For our first step in this example, we're going to define some vectors to test and actually display those vectors as lines in Dynamo. So to define the vectors that we're going to test, we're going to define an origin point using point by coordinates and kind of set up a vector on the z-axis. There's a nice node vector.z-axis that'll help us do that. Then we're going to create a vector from the origin to some movable point. Okay, we're going to basically go through and use vector by coordinates to create that vector, and then we're going to normalize that vector. Okay, that's going to go ahead and, although it may have a length because the points are not equally spaced away from the origin, it could be growing longer. Vector normalizing will actually reduce that so it has a unit length of 1. That way our dot product arithmetic will kind of be consistent. Okay, we're also going to go through and create a vector from the origin to the sun's position. Okay, we're going to find out where the sun is using something called sunsettings.current. Okay, we're going to get that sun direction. Again, we're going to normalize that vector because, again, it'll have a long length and we want it to all be considered kind of the same unit length for comparison. After we've kind of set up those vectors, we're going to display these vectors as lines in Dynamo just so we can visualize them. Okay, we could use vector as point that converts vectors to a point so that we can then say line by start point, end point, going from the origin to that end point. Okay, and that way we'll have lines that actually represent those different vectors. Okay, let's go ahead and show you how this all works. So here we have basically a point at the origin, so just point at coordinate with 0, 0, 0. We have vector z-axis. Let me go ahead and just run this for you first. And it creates a vector with x of 0, y of 0, z of 1, because it's pointing straight up in the z direction. Okay. Then we're going to go through and create a vector with a movable endpoint. Okay, that's the one we're going to slide around a little bit. I'm going to start it at x of 1, y of 1, and then give it a z value that'll slide around. Okay, so we'll just basically do the x coordinates, the y coordinates, and the z coordinates going to be controlled by this number slider. Okay, then I'm going to normalize that vector. Let me kind of show you why that's necessary. So if I run this, here's the vector. And if I can pin that down for you right now. A little hard to get that. It has a length of like 2.8 or something like that. That's just because of where things are located right now. If I normalize that vector, okay, it's going to keep the same distance. But the idea is this has a uniform length of 1. So that when we start multiplying things together, will just work out to be a little more consistent. Okay, similarly, we're going to create one more vector. This is going to basically point towards the sun. There's something called sun settings current that gets the sun direction. Now where that comes from is there's something over in Revit called the sun path. And if you get into the sun settings, you can actually sort of see for Stanford, California, on the spring equinox at 12 noon, we have the sun set to there. Okay, and if we move that around a little bit, for example, if we move that to 1:30 in the sky, let's see if it'll update itself over there. I can do it through this dialog, or I can do it like I showed in the overview, where I just do it right within the Revit environment. Let's move that around a little bit. There, it jumped around a little bit, or I can do it over here. The sun's moving around. And again, that'll change depending on what time of the year it is. So if it's not in March, it could be in June or in December, whenever you want it to be. Okay, so basically we have the sun's location. We're going to pull that off, get the sun direction. That's a vector to the sun, kind of pointing toward the sun. And again, I'm going to normalize that. Now, once we've basically created all these vectors, I'd like to visualize them. So what I'm going to do is get that z-axis vector as a point, and we're going to go a line from the origin to the z-axis. Let's see, you can see it right there. Okay, there it is. Let's go back, and this is going to be to the movable line, again going from the origin to wherever my movable line is. And you see it's actually lying relatively low right now. And we're also going to get that vector to the sun from the origin towards the sun. Okay, now it's pointing at the sun. So the z-axis, the movable point, the sun one. Okay, and that's all really just there for the purpose of visualization. Okay, great. So we've created our basic vectors and we can visualize them. Next, we're going to go take a look at actually kind of computing what the dot products are between the different vectors and think about how we can use that numeric value.